Hi dear my students, welcome to day 4 mathematics class for class 10 students. The chapter name is real numbers. Until yesterday we have completed until theorem 1.6 and also applications of theorem 1.6. Today we are going to discuss about the new topic, that is logarithms. Let us know the definition at first. If n and a, here something we wrote within brackets. You observe carefully this. If n and a, of course a is not equals to 1, are any two positive real numbers and for some real value x, a power x is equal to n, then x is said to be logarithm of n to the base a. It can be written as log n. How can we read this? Look at once the blackboard. Log n to the base a. Here a is known as base. Log n to the base a is equal to x. Once again, go through the definition of logarithms. If n and a are any two positive real numbers and for some real x, a power x is equal to n, then x is said to be the logarithm of n to the base a. Its symbolical form is log n to the base a equals to x. Here two things are there. What are they? A power x is equal to n and log n to the base a equals to x. Here a power x is equal to n is known as the exponential form. We know very well, it is familiar to us. A power x is equal to n is the exponential form, and log n to the base a is equal to x is its corresponding logarithmic form. So log n to the base a equal to x is the corresponding logarithm of this exponential function. Let me explain through some examples. You see, a power x is equal to n is the exponential form. When this exponential form changes as a logarithmic form, how it changes? Log n to the base a equal to x. Let us see here one example. For example, 3 power 4 is equal to 81. Is it correct or not? Once you found 3 power 4, 3 3s are 9, 9 3s are 27, 27 3s are 81. 3 power 4 is equal to 81 is known as the exponential form. We know very well exponential functions. When this exponential form can be changes in terms of logarithms, how it will be changed? Anyway, you want to write log, you just compare the terms with the above step. Here a power x, 3 power 4 is there. That value is n. Here that value is 81. Log n, log n. Instead of n, what should we write? 81 we should write. Yes or no? What is the value of a here? 3. Now that value becomes 4. See, let us, how this can be changes as this. Let me explain again. From logarithmic form, can we able to get an exponential form or not? Let us see. Take this value again. Log 81 base 3 is equal to 4. We know the power notation of 81. 81 is nothing but 3 power 4. So the next step changes as log 3 power 4 base 3 equals to 4. Now here this power comes as first. 4 log 3 base 3 equal to 4. So this value log 3 base 3 value is 1. 4 into 1 is equal to 4. So 4 is equal to 4. In the same way we can show any logarithmic form how it should be equated to exponential form. Okay, let us note down the logarithms definition. Let us come to laws of logarithms. First one is a power log n to the base a equal to n. First formula is a power, this is not base a, this is base a. You observe carefully. Log n to the a power log n to the base a value changes as n. Second formula log xy to the base a equal to log x to the base a plus log y to the base a. Third formula is log of x by y to the base a equal to log x base a minus log y base a. Fourth formula is log x power m to the base a equal to m log x. See, before laws of logarithms, after the completion of definition of logarithm, here we might have explained something. 3 power 4 is equal to 81. This is an exponential form. When we change this exponential form as logarithmic form, log 81 to the base 3 equal to 4. You might have observed or not. Once again I am going to give the explanation for this condition. Log 81 to the base 3 equals to 4. Is it correct or not? Once we check. Log 81 means 3 power 4. It's exponential form. And base 3 equal to 4. Here in this step we use this formula. Log x power m to the base a. X to the power m is there. That m comes as before logarithm. You might have observed or not. Here a is there. So automatically here 4 comes here. 4 log 3 base 3 equal to 4. And here the next formula is log a to the base a equal to 1. That means here logarithm of any number with the same base, that value becomes 1. Of course here also we use the same condition. So automatically log 3 base 3 value becomes 1 only. So 4 is equal to 4. Not only this one, you take any value. Log x to the base x is equal to 1. Log 7 to the base 7 is equal to 1. And last one is log 1 to the base a equal to 0. Log 1 to the base a equal to 0. How it is possible? The last one, sixth one, how it is possible? Let me explain. We know very well a power 0 is equal to 1. Not only a power 0, 2 power 0 is equal to 1, x power 0 is equal to 1. So this condition is familiar. We might have studied in our 7th class level. See, this is an exponential form. Actually, this is an exponential form. When we convert this as logarithmic form, how this exponential form changes? Once you compare this with a power x is equal to n. What is the definition of logarithm? Log n to the base a, log 1 to the base a equal to this value comes as 0. Yes or no? So that is the case, log 1 to the base a equal to 0. So that is the reason in our introduction part, when we wrote the definition of a logarithm, let us consider n and a are the positive real numbers. But when we mention a, we wrote within a brackets not equals to 1. A value you must not take 1. So these are all the laws of logarithms. Please note down these formulas. Apart these 6 formulas, we need to discuss about the second one and third one. We need to prove these two formulas. Why? Because there is a chance to ask the solutions of these two formulas in examination point of view. Okay? So before giving the explanation, please note down these formulas. Okay, let us go through the solution of log x to the base a equal to log x to the base a plus log y to the base a. How can we prove this? Listen carefully. I told you previously, this is very important question. There is a lot of chances to ask this question as 2 mark question in an examination point of view. So you must know this is solution. Let us see the solution. Let log xy to the base a equal to p, log x to the base a equal to q, log y to the base a equal to r. Here I don't want to take LHS and I am not supposed to prove RHS, or else I am not going to take RHS and I don't want to supposed to prove LHS condition. Here you see, I would like to take all the 3 terms. Here I took log xy to the base a equals to p, log x to the base a equals to q, log y to the base a equals to r. Means all the 3 logarithmic forms I would like to equate some other variables. After this, I am going to write all the exponential forms. Means I want to avoid logarithms from these 3 steps. So exponential forms are, how we get exponential forms? A power p is equal to xy, a power q is equal to x, a power r is equal to y. Yes or no? You know very well, log n to the base a equal to x, which implies a power x is equal to n or not. This is the logarithmic form and this is the exponential form. Now I am going to write like this. Means I want to avoid all the logarithms and I am going to write all the exponential forms. Let us see. First one, a power p is equal to xy. Say this is first one. A power q is equal to x. Say this is second one. A power r is equal to y is third condition. Here what I will do, I want to multiply second equation and third equation. So second condition I would like to multiply with third equation. What will happen, you see? When we multiply 2 conditions, both the LHS should be multiplied in one side and the rest of the corresponding RHS conditions should be multiplied on the other side. So here LHS is a power q and here LHS is a power r. A power q into a power r is equal to x into y. We know very well, if bases are equal, power should be added. Yes or no? A power m into a power n is equal to a power m plus n. We know very well. A power q plus r is equal to xy. Bases are equal, power should be added. That means instead of two bases here we took only one base. Now that value equals to xy. Okay, what can I do now? From first equation, a power q plus r is equal to, according to first equation, instead of xy, may I write a power p? Observe carefully. Every one of you observe carefully. Here RHS condition is xy. So here RHS condition also xy. So instead of xy, may I take a power p? Yes, a power p. So what we understood here, bases are equal, powers are also equal. Bases are equal, powers also equal. Bases are equal, powers are also equal. Therefore, what are the powers here? LHS is q plus r and RHS is only p. So we get one equation, q plus r is equal to p. Actually, according to our assumption, what is the value of q? You see, q is nothing but log x to the base a. So may I substitute log x to the base a instead of q? Log x to the base a plus, what is r value? This one. Log y to the base a. What is p? Actually, log xy to the base a. Log xy to the base a. Hence, we proved. Any doubts? Did you understand, everyone? Very good. Okay, note down this condition. Okay. Let us go through the second very important formula, that is log x by y to the base a equal to log x to the base a minus log y to the base a. Let me explain this solution. So concentrate carefully on this solution. Let log x by y to the base a equal to p, log x to the base a equals to q, log y to the base a equal to r. How do we assume in the above problem? The same, like that only we assume the three terms. So one term we are equating to p, second one we are equating to q, and the final one is we are equating to r. After writing this like above, I am writing exponential forms. Exponential forms. What are the exponential forms? A power p is equal to x by y. A power q is equal to x. A power r is equal to y. Can we say this is first one, this is second one, and this is third one? If you might have observed, when we explain the above formula, second equation and third equation I multiply. Why? Because if you observe properly the LHS condition, log xy to the base a, there in the above problem, log xy to the base a, that is the LHS condition. So anyway, x and y are multiplied. So that is the case in their above solution. I multiplied 2 and 3 conditions. But here you observe what will happen. X and y are multiplying or dividing. So due to the symbol division, second equation and third equation, now I am not going to multiply. I want to divide. Listen, second equation by third equation. What will happen? A power q by a power r is equal to x by y. We know well-known formula, a power m by a power n is equal to a power m minus n. Now, how this value changes? A power q minus r is equal to x by y. Instead of x by y, what can I take? A power p. How? From first equation. Like above, as bases are equal, powers are also equal. As bases are equal, powers are also equal. Here base is A and RHS base is also A. Now write the rest of the terms. Q minus R is equal to P. Actually, what is Q according to our assumption? Log x to the base A minus what is R? Log y to the base A is equal to what is P? Log x by y. Log x by y to the base. Hence the solution. Please note down this condition. Okay, students, based on the above laws of logarithms, now I would like to explain the three problems. So let us concentrate on these three problems. First one, determine the value of log 512 base 2. Second one, write log 10 plus 2 log 3 minus log 2. Actually, there three logarithms are there. We are asking to minimize as a single logarithm. Minimize means we want to simplify all these three, and finally we are asking to convert as a single logarithm. And this is we are asking to expand it. This is actually expanded form. We are asking to write here short form. This is short form is given. We are asking to write expanded. Let us see these three solutions. Let log 512 base 2 is equal to x. What is the exponential form? What is the exponential form? That means what? We are avoiding logarithm. The exponential form is nothing but 2 power x is equal to 512. Let us divide here 512 with 2 table. 2 table, if you divide, it possible for 256 times. And now 2 128 times, 2 64 times, 2 32 times, 2 16 times, 2 8 times, 2 4 times, 2 2 times. Once you count how many 2's are there in this bracket. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 power x is equal to, instead of 512, may I write 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 power 9. As bases are equal, powers are also equal. Actually, what is x? What we assume x? Log 512 base 2. It is nothing but the question. Therefore, log 512 base 2 is nothing but 9. That value is 9. Let us go to the second problem. Actually, here expanded form is given. We are asking to convert this expanded form as a short form. How can we do this? Let us see the solution. Log 10 plus 2 log 3 minus log 2. Log 10 plus 2 log 3. Here we wrote laws of logarithms. According to that, can we send the 2 as the power of 3? That is log 3 square minus log 2. That is log 10 plus log 3 square means 9 minus log 2. Here we use the first formula, log x to the base a plus log y to the base a equal to log xy to the base a. That means can we combine these two? So log 10 into 9 minus log 2. It is nothing but log 90 minus log 2. Here also we want to use one more identity, that is log x base a minus log y base a equal to log xy to the log x by y to the base a. Now can we change it as log 90 by 2. 2 table 45 times cancel. Now the simplified form is log 45. Actually here 3 logarithms are given. That means expanded form is given. We are asking to write its simplest form. But what is the variation between second sum and third sum? In second sum, expanded form is given. We are asking to write its simplified form. But in question number 3, simplified form is given. We are asking to convert it as expanded form. Let us see. Solution. Log p square q cube by r is equal to, may I write log p square q cube minus log r. Why? Because of this formula only. How do we get this? Log of x by y to the base a equal to log x base a minus log y base a. And again, in between these two terms, can we use this first formula? Yes. Log p square plus log q cube minus log r. How we get two logarithms from this step? Because of this formula. What is that formula? Log xy to the base a equal to log x to the base a plus log y to the base a. Again, here you see 2 comes as power of 3. So 2 we will get as 2 log 3. So 2 comes here. 2 log p plus 3 log q minus log r. Here also we use a formula. Log x power m to the base a equal to m log x to the base a. So this is the shortest form and this is the expanded form. So once you get the 3 problems and anywhere you may have doubt, just ask me. If you don't have any doubt, please note down these 3 solutions. Did you all completed writing these 3 questions? Okay. So based on the above explanation problems, I have given 3 homework sums. Please note down. Determine the values of a bit log 32 base 2, b log root x base x. Second one, write 2 log 3 plus 3 log 5 minus 5 log 2 as a single logarithm. That means here full form is given, expanded form is given. We are asking to convert it as short form. Expanded log 128 by 625. That means simplified form is given. We are asking to write it its exponential, expanded form. Hope will you do this 3 sums? Okay, right. Note down. Thank you.